Hello students, welcome back to my channel. Today we are going to discuss a very important topic of class 12 board exams, and in electrochemistry we will read this topic. It is very important topic for board students as well as for higher sections. So today we are going to discuss migration of ions. Okay, migration of ions. What is migration of ions? We know that in electrolytic conductor, we know that in electrolytic conductor, the movement of ions allows to pass current. Without movement of ions, we cannot have the current. Okay, so in electrolytic conductor, what is electrolytic conductor? An electrolyte solution contains container. Okay, that is your electrolytic conductor material. For example, this is your one container like that, and in this container only you have one electrolyte as NaCl. NaCl is nothing but a strong electrolyte, also called as sodium chloride, a common salt. So this NaCl solution, when you put some water, okay, in this container, and then you put some pinch of salt in it, the NaCl will dissociate into Na positive ion plus Cl negative ion. Okay, so this Na positive is nothing but a cation, and this Cl negative is nothing but an anion. So this Na positive will behave as sodium ion, and this chlorine negative will behave as chloride ion. Okay, so these two ions dissociate from each other. Okay, and then they will move into this beaker only, into this container only, when you put some water. Okay, so in contact of water, the electrolyte tends to break into their constituent particles, into their constituent ions, and that only we are having this Na positive and Cl negative as their respective ions. Okay, so this is one your NaCl, about 1 mole of NaCl. So NaCl is a type of electrolyte. What type of electrolyte? A strong electrolyte. What is strong electrolyte? A strong electrolyte means when any strong electrolyte pour into any water or any other kind of solvent particle, the strong electrolyte tends to dissociate into their whole ions. For example, if 100 mole of NaCl, if we put 100 mole of NaCl into the water, the 100 mole of NaCl will give you 100 mole of Na positive and 100 mole of Cl negative. That is the meaning of strong electrolyte. And what is the meaning of, on the other hand, what is the meaning of weak electrolyte? The weak electrolyte doesn't have the property to give you complete ions, complete mole of ions that you have taken first. For example, any kind of weak electrolyte you can take, like HCN, okay, or any other kind of weak electrolyte you can take. Not all salts are only considered as to be electrolyte, but yeah, acids, bases, all can break into their constituent particles, all can give you the ion form. That's how it is not correct that only salts are considered as to be the ion form, the electrolyte form. Okay, the salts are able to give you the cation and anion, but the acid and bases are also able to give you the anions as their hydroxide ion from their base, and as per their proton, which means H plus, as from their acidic mediums. So it is not correct that only salts are considered as to be electrolyte. The bases and acids are also considered as to be electrolyte, as they are able to give the ion form when they can discussed in the matter of electrolyte. Okay, so NaCl is a kind of electrolyte. So what kind of electrolyte it is? It is a kind of strong electrolyte. Okay, it is a kind of strong electrolyte. So write one point. that NaCl is a kind of strong electrolyte. NaCl is a strong electrolyte. In this case, the strong electrolyte is very important to understand the migration of ions, because the migration of ions is totally depends on that property also, that what kind of electrolyte you have poured in the particular container. If the electrolyte is weak, so the property of the weak electrolyte is different from the property of strong electrolyte. So in the case of strong electrolyte, the conduction, or you can say the conductance will more as compared to the conduction of weak electrolytes. So in the case of strong electrolytes, we are not supposed to take any tension to move the ions or to move the current also. So in the case of NaCl, if you are taking the NaCl, a kind of strong electrolyte, so we are not supposed to take any tension that how the current will move, because in the case of NaCl, in the case of salt, in the case of this strong electrolyte, the current will pass very fluently. Okay, so let us understand our today's topic, which is our migration of ion. It is also important because it is one demo that how we will move towards the migration of ion study. Okay, so let us start the migration of ion, and this migration of ion is studied by one scientist, and in that case only we will see one experiment that how the migration of ion take place. Okay, so let's start the migration of ion study. Okay. So in this case, we're supposed to take one U-tube like that. Okay, this is your U-tube. This U-tube is available in any kind of laboratories, and in this U-tube only we will see the experiment. Okay, when migration of ion, how the ions move from one path to another. Okay, so in this case, migration of ion you will see, and for having the correct evaluation of migration of ions, you need to take one indicator, for example phenolphthalein, to indicate the base properties. For example, if you're having any base and if you pour phenolphthalein, okay, you will get a pink solution. Why? Because the base or you can say the phenolphthalein is used to check the base is there or not, because phenolphthalein indicates the pink color when it came in contact of base. So phenolphthalein we will take for this particular experiment, because we want to see that how the base and acid ion move from one place to another. Okay, so in this case we will take phenolphthalein as an indicator. Okay, so here I have taken one U-tube. Okay, and in this U-tube only we will pour KCl. KCl, you know, KCl is also kind of strong electrolyte like NaCl. So KCl is also kind of strong electrolyte. It is a salt, but it is a kind of strong electrolyte only. So when you put KCl in water, it will give you K positive potassium ion as well as chloride ion. So KCl is a kind of strong electrolyte, and it will completely dissociate into the mole which you have taken as the measurement. Okay, so if you take 100 mole of KCl, 50 mole of KCl also, it will give you 50 moles of K positive and Cl negative as you move forward towards the experiment. Okay, so in this particular U-tube I have taken the KCl as our strong electrolyte, and in this strong electrolyte you will able to get the current, okay, very easily. And in this current only you will get which kind of current, conductance, which conductance, molar conductance. Okay, so this is your KCl. Okay, and in this KCl you will put some agar-agar. Okay, agar-agar, and also phenolphthalein. You know, phenolphthalein is used to check that base is there or not. Okay, you know that in elementary classes we have done one experiment as neutralization reaction. In that case we have used the phenolphthalein as an indicator to check the base is there or not. If the pink color is appeared in the solution, then we got the result that our base is there in the solution. Okay, in this case also the phenolphthalein if we put, and then if we put the base like NaOH, any kind of KOH, then it will give you the pink color in the result of the basic medium. So phenolphthalein, it is a kind of indicator. once remember that it is a kind of indicator to indicate the basic medium is there or not. Okay, if the pink color is not appeared, then it is very usual that acid is there. Okay, because in the acidic medium it shows colorless properties. Okay, in basic medium it will show the pink color property. So in this YouTube you will having the KCl as a very strong electrolyte and agar-agar, okay, and phenolphthalein indicator. Okay, so 3 things you have to pour in this particular YouTube. So in this particular YouTube I have taken these 3, okay, together, and then after some time it gets some jelly-like structure, semi-jelly-like structure, and after some time you have to pour the acid and base in it. For example, this is your mark where I have closed this YouTube like 2 parts. Okay, to not get acid and base together, I have separated one mark with any kind of, you can take any kind of paper or any kind of a chip to get separated from the acid and base solutions. Okay, so this is your mark. One side you have to pour the acid and one side you have to pour, as you know that it will be a base. So this is your first, I have taken the YouTube. First I have taken this YouTube, and in this first YouTube I have taken KCl, agar-agar and phenolphthalein. Okay, after some time when it gets semi-solid, then you have to pour the NaOH and HCl. Okay, what is NaOH? NaOH is your base. Which base? Strong base. And HCl, which is your a kind of strong acid. Okay, it is a NaOH base and this is your HCl strong acid. Okay, this is your strong base, this is your strong acid. Okay, now you have to pour in this poured as KCl agar-agar phenolphthalein solution. You have to pour NaOH and HCl only separated tubes. Okay, this is your one separated tube, this is your one separated tube. In this particular you have to pour NaOH, which is your sodium hydroxide, and this is your HCl, this is your HCl is what? HCl is what? Hydrochloric acid. Okay, now I have poured this NaOH towards this, okay, and this particular tube I have poured the HCl acid. Okay, now when you pour this HCl acid, you will see that no color will appear. Okay, this particular tube, from this point up to this point, no color will be appeared. Why? Because this particular container, this whole container is filled with phenolphthalein, you know. So phenolphthalein is only measured to indicate the base only. So if base is not there, only acid is there. So in acidic medium, the phenolphthalein is not able to give you any kind of result. Okay, any kind of color. So in this particular acidic medium, this particular site, only up to this and this mark you have to see, this particular site will not give you any kind of color. So in this particular tube, it will give you the colorless form. Okay, so it will be colorless. Why? Because H plus will be there. Okay, HCl is there, so H plus will be there. So in the case of HCl, phenolphthalein is not able to give you any kind of color. Okay, when you pour NaOH, on the other hand, when you pour the NaOH, the OH negative is what? OH negative is nothing but your hydroxide ion, and H positive is nothing but your hydrogen ion. So when you pour the hydroxide ion, or you have to pour the first NaOH, and then when you pour the NaOH towards this side, you will get the Na positive and OH negative separated as their dissociation, and then the OH negative will move towards this container, and after some time this container side up to this, from this to this, it will give you the pink color. It will give you the pink color like that. Why? Because phenolphthalein is indicate to check that base is there or not. So we are having phenolphthalein all over the tube, and when you pour hydroxide ion, okay, when you pour the NaOH, the hydroxide ion gives you the result that phenolphthalein is there, and when phenolphthalein came in contact of hydroxide ion or any kind of basic medium, it will give you the pink color. Okay, so in this pink color you will get the result that the base is poured in the phenolphthalein. Okay, now you have to mark as their tip point of the U2 to check the mark of their movement. Okay, because our third step is totally depends how the ions will be migrated. Okay, so migration is means that how the thing is going from one place to another. Okay, so we have to see that how the ions migrated. So in the third step you will see that how the ion will be migrated from one place to another. Okay, now I have to make one more U2. This is your one more U2. Okay, little bit. Correct only. Now you have to pour in this particular. Okay, no, it is not a new U2. Okay, it is the done experiment you have taken. So this is the U2 like that only. Okay, now you have to pour HCl plus CuCl2. HCl plus CuCl2. In this only you have this pink color as the NaOH is there. It is not any kind of new U2 I have taken. Okay, this is the continuous experiment I have done. Now, when you pour HCl plus CuCl2, you will see in this you will pour HCl plus CuCl2. You will see that when you pour CuCl2, okay, when this particular site came in contact with CuCl2, because we have poured CuCl2 plus HCl, so when this particular site came in contact of CuCl2, then the CuCl2 copper will deposited over this tip of the U2 like that. This blue color will be marked as the CuCl2. Okay, and this particular blue mark is nothing but your CuCl2 solution. CuCl2, because of CuCl2 this blue mark is appeared. Okay, now this is HCl, this is CuCl2. Now just wait for some time. Now we have to pour NaOH. Okay, we have to pour NaOH to this container where HCl is there. NaOH. This is filled with how many materials? Phenolphthalein, agar-agar, KCl, also HCl. Now we have to pour NaOH, which is your strong base. When you pour NaOH, okay, what will happen? Because one thing you have to remember, that this particular site and this particular site is in higher quantity of HCl or NaOH. Okay, so when you pour HCl and NaOH vice versa, then it doesn't give you the result as soon as you are thinking. Okay, so when you pour, you have to make sure that you have to connect this U2 with a battery. Okay, so just I am doing one battery system like that. This is your positive terminal, this is your negative terminal like that. I have made circuit, I have made the battery system in it. Okay, now you have to start the battery. Okay, and then the current will be going on. Now we have to check that how the current will be going on. Okay, now when you start the battery, what will happen? The work of the battery is nothing but the movement of electrons, movement of ions. So in this electrolytic conductor, the movement of ions is there, okay? That will be nothing but your charge carrier. And in the metallic conductor, the movement of electrons is there. So it is not the metallic conductor, it is the electrolytic conductor, it is the experiment of electrolyte. So in this electrolytic conductor, when we are doing the battery, when we engaging the battery, what will happen? The positive terminal and negative terminal will be there, and we know that the ions are likes to attracted towards the opposite charged ion. For example, if Na positive OH negative is there, so it will behave as a Na positive and OH negative when they came in contact with these solutions, okay? And in this particular, the H positive and Cl negative as well as Cu2 positive and Cu2 means 2Cl negative is there, okay? So there are total 3 ions we are there, and Na positive, OH negative, Cu2 positive and H positive, Cl negative is there. Okay, now which one is positive terminal, which one is negative terminal, you have to see. Okay, for example, if OH negative is there, is there, so it is not your negative terminal, means it is your negative, it is not your positive terminal, it will be your negative terminal. Okay, for example, this is your negative terminal and this is your positive terminal. Okay, now the OH negative is likes to go towards the positive terminal, because this is a positive terminal, positively charged electrode, and this is a negatively charged electrode. And this OH negative, when came in contact with the solution part, this OH negative will move towards the positive terminal. This is your positive terminal, this is your positive terminal, right? Now when the OH negative moves towards the positive terminal, what will happen? The OH negative, when came in contact with phenolphthalein, the indication will be pink color. So when the OH negative goes towards this side, it will give you the pink color. Okay, whatever part it going towards this positive terminal, this particular colorless side will become the pink colored side. Okay, so what will happen? When OH negative moves, okay, I want to write moves, the pink color will be there. Okay, pink color will be there. All of a sudden you will see when the OH negative, because the OH negative is poured from top of the container, okay, so from top of the container, when the OH negative filled, the OH negative starts moving from there, and then gradually it will reach up to there. Okay, and when the movement of ion is there, you will get the current also in the electrolytic conductor. So when the OH negative moves from there to there, it will give you the pink color. Okay, on the other hand, this H positive or Cu2 plus is also kind of cation, or you can say positively ions. So when H positive, okay, first we are saying the H positive, when the H positive moves towards this side, because the negative terminal is there here, so H positive likes to get attracted towards this negative terminal. When the H positive get attracted towards this negative terminal, what will happen? The H positive, whatever the part the H positive moves, this particular pink color will be vanished. Okay, so when the H positive, just look at this side, okay, when the H positive moves, the pink color vanished, and the colorless side you will see. Okay, the pink color will be vanished, the pink color will be vanished, and you will get like that of colorless points. Okay, and when the Cu2 positive, because Cu2 positive is already running, so when the Cu2 positive moves, okay, what will happen? This particular blue part, you will see that a particular blue part will be going on, okay, in this particular side up to there. Like that. this case, we have seen that how the ions get migrated from one side to another side. Okay, and in higher sections or in more detailed study, you will read that how the speed of ion dependent or the concentration is dependent towards the speed of the ion. Okay, so in this case we have seen that how the migration of ions takes place, and with the help of migration of ion we will get the current, we will get the electricity, and these all is dependent all about the electrolytic conductor only. So I hope you have enjoyed this video, and if you like the video, then please do like, share and comment, and subscribe to my YouTube channel. And if you want more videos like today's video, then please comment that we like the video and we want more video like that. Okay, so keep studying, and all the best for your exams. Thank you.